Hey everybody, welcome to Embatronics. I hope you are all doing great. In this video, we are going to demonstrate the SPI in NUTX RTOS using the OLED display. I am dividing this video into three sections: SPI driver, SPI application, and demonstration. Let's get started. First, we will discuss about the SPI driver in NUTX RTOS. NUTX RTOS has the SPI device driver already, so we can use that. But at the time of recording this tutorial, ESP32 does not have initialization of the SPI bus and the driver. So we are creating the new custom driver to initialize the SPI bus and the driver. In our custom driver, we have taken SPI2 and SPI3 bus. We have created the ETX SPI driver init function. In that, we are initializing the SPI2 and registering that SPI bus 2 to the SPI driver. The same thing we are doing for SPI3 also. This header file has the declaration of that function so that we can call this function from anywhere by using this header file. In ESP32 bringup.c, we are calling this function, so SPI will be initialized automatically after the boot. Next part is SPI application for SST1306 OLED. In the application directory, we have created the two files called etx SPI SST1306 app.c and .h file. You can see there is a 1024 bytes array called ETX logo. This array contains the image that we are going to print. Another array contains all the possible characters to print. Let's go to the entry point, which is main function. In the main function, we are creating the task called ETX SPI SST1306 task. If we get any error, then we return from the main function. Once the task has been created, it starts executes. Initially, we are opening the GPIO driver. After that, we are configuring the reset and DC GPIOs. Right after that, we are opening the SPI driver. Once everything is ready, then it is a time to initialize the OLED by sending couple of commands. We are placing the cursor to 0th column and 0th row position and setting the brightness to high. Turning off the invert mode. Then enabling the horizontal scroll functionality just for the first 3 pages. Once after setting up the OLED, we are writing the Welcome to Embatronics string on the OLED. This will be scrolling for 9 seconds. After that, we are clearing the OLED, then deactivating the scroll. In a continuous while loop, we are putting the display into invert mode. As we have image data in the array, we are sending a byte by byte data to the OLED. After 0.5 seconds, we are turning off the invert mode. Basically, the idea is to make the image to blink like flashing. This will be running continuously. If we found any error, then we unregister the GPIOs and close the drivers. The other functions of this file are just implemented based on the OLED commands, so you can understand easily. This is the OLED init function where we send few commands to initialize the OLED. This ETX SPI SST1306 write function is used to write the data or command to the OLED display. I have not explained all these functions here as these functions are self-explanatory. This header file has all the required macros and variable declarations. It's time to work out. Before that, some of them might think, why should I display Embatronics logo on my OLED display instead of our own picture? This part will help them to do that. Windows users can download the LCD Assistant application from this website. The website link has been given below. You will get the zip file, then you can extract that. I have extracted the app already. I have taken the image that I want to print. Let's edit this. First, resize the image to 128 x 64 pixels. Then, convert that image to monochrome bitmap image. Open the LCD Assistant app and load the bitmap image. Byte orientation should be vertical and keep the other settings unchanged. Finally, save the output. You will get an array. If you don't want to use the LCD Assistant app, then web version also available. Go to that image to CPP website, choose the bitmap image and keep the default settings. Change only the draw mode to vertical. Press the generate code. You will get an array here also. You can use any one of this array. I am copying the array and paste it to my code. Let's build the code. In menu config, first we will enable the SPI2 of the ESP32. You can change the MOSI clock pins if you want and connect it properly to the OLED display. Then enable the SPI driver. Now we will enable our driver which we wrote already. Enable the Embetronics GPIO driver and SPI driver. Then finally we have to enable the application. Check the reset and DC pin numbers. You can change this too if you want. Exit and save the menu config. Flash the code and connect the serial terminal. We have our app. Connect the ESP32 and OLED properly. Some of the OLEDs might not have chip select or chip enable pins as they have connected that pin to the ground already in the board. Now run the app. Welcome to Embetronics. I hope you might have learned some new stuffs by watching this video. I have provided all the required links in the description section. Please check it out. Thank you and meet you soon with another good tutorial.